So hello everyone and welcome to the Europlanet webinar of April 2019. This is part of the monthly webinar series organized by Nucleo for Europlanet on planetary sciences. My name is Nuno Gomes. I'm an astronomer working at Nucleo in Portugal, and I'm currently talking from Porto in the north of Portugal, and I will be your host today. Joining me is Julie Nováková. Julie is an award-winning Czech author of science fiction and detective stories and a scientist, currently a PhD student of evolutionary biology at the Charles University in Prague. She has published 7 novels, 1 anthology, and over 30 stories in Czech, plus several short stories in English in Asimov's, Clarkesworld, and other magazines and anthologies. Julie is also a young mother. She has a baby daughter of 7 months. Is that right, Julie?
Yeah, it is. Hello.
Hello. How are you?
Thank
you so much for accepting our invitation. It's a privilege having you with us today.
I hope people enjoy it.
I'm sure they will. Julie is going to talk about a very interesting and engaging topic, the possibilities of life outside our planet and the link between science fiction and the science of celestial bodies. Is that right?
Yeah, it is.
Okay, great. At the end of Julie's presentation, we will have a Q&A session. So if you who are joining us today have any question you would like to ask during the presentation, please use the dedicated app or the chat window available in Zoom to write down your questions. After the presentation, we will read your question and Julie will answer it. Okay? So I think we are ready to start. Julie, you have the word.
Okay, perfect. So let me just share the screen. Okay, just a second. Okay.
Julie, just tuning the screen in order to share the presentation with all of us. She's going to be ready very shortly.
Yeah, I'll probably just use this window. It will be better. Yeah.
Okay.
Thank you for joining me today. Search for life is a very interesting, engaging topic. And it's a very up-to-date one because right now several missions that are going to search for signs of past, extinct, or even existing present life are being prepared. But it also has a rich history. People have always imagined the chances of finding life on other worlds or even the existence of other worlds. Ancient Greek philosophers such as the atomists, or then philosophers and theologians in the Renaissance imagined the possibilities of countless worlds such as the Earth. And the popular imagination has always been rife with stories of life on other objects, such as the Japanese tale of the bamboo cutter, which featured a moon princess we can see here receding back to the moon on her chariot. And we also have depictions of life on the moon in Orlando Furioso, or even in Johannes Kepler's posthumously published novel Somnium. So the possibility of life on the moon, though we now know that it's a completely lifeless object, has been here for many centuries because we have been staring at the face of the moon from the beginnings of humanity and wondered whether there could be life. And later on, when we discovered that other dots in the sky may be planets such as the Earth, people have been wondering whether these can have life as well. And for a long time, it remained the domain of philosophers such as Immanuel Kant, who actually believed that life is abundant in the solar system, and that the further we go from the sun, the more intelligent, advanced, and noble the civilizations are. So that we could, for example, find the Jovians much more cultured than us. And on the other hand, the Mercurians would be very basic, very, let's say, intuition driven. But of course, that was before the advent of really modern science. And afterwards, everything changed. And let's start with several objects that are up to this day possible sites of searching for life outside of the Earth. And the closest to the sun of these objects is Venus. It's sometimes called Earth's twin sister because it's almost the same size and mass as the Earth. But it wouldn't be able to get much more different in terms of the surface conditions. When we look at Venus in the visible light, we see that all of it is covered in impenetrable clouds, so that we haven't been able to look at its surface before start of planetary missions. And for a long time, people have tried imagining what's underneath these clouds. And in the beginning of the 20th century, this gave rise to lots of pulp science fiction featuring Amazons and dinosaurs and strange civilizations of Venus. And people, not just writers, but also lots of scientists, imagined Venus to be covered with swamps or tropical forests because it's closer to the sun than the Earth. So they imagined that it would be sort of like a warmer variant of the Earth. And even some astronomers who observed it became convinced that they can see some kinds of surface features of Venus, like we see here on this map. Of course, these were optical illusions, as we now know, but it was still uncertain in the 19th and beginning of the 20th century. The French popularizer of science, Camille Flammarion, said that if Venus were without population, then the Earth must be similarly lacking. And we see that this argument doesn't really hold, but he still imagined Venus to be something like this, you know, canyons and seas and forests, all covered by these thick clouds. And scientists such as the Scandinavian physicist Svante Arrhenius were also convinced that Venus may have life. And Arrhenius said that it's likely covered with swamps, and there may be coal deposits akin those that were formed on Earth earlier. And he also thought that it only features slow forms of life, like plants and insects and so on. But later on, it became clear that Venus may not be a very hospitable place. Already before the wars, spectral observations show that it has a lot of carbon dioxide, which is a very strong greenhouse gas, so that it may in fact be much warmer than we would expect just based on its distance from the sun. And in the 1960s, in the age of planetary missions, when Mariner 2 did its first flyby of Venus in 1962, it showed us that it's a very inhospitable place because it measured temperatures exceeding 300 degrees Celsius. And nowadays, we know that the surface temperature on Venus is around 460 Celsius. So it's really far away from anything that life as we know it can endure. And the Soviet Venera probes, several of which landed there, also confirmed this image of Venus. But although it's a hellish greenhouse nowadays. It may not have been always so, and Venus may have started as a similar planet as the Earth, with liquid oceans quite soon after its formation. And it's a big unanswered question of how long did it keep these oceans before they evaporated and before the runaway greenhouse scenario started. And some scientists are convinced that it basically never had liquid water oceans because it never cooled down enough. And other ones, such as, for example, Bullock and his colleagues have run models that allow liquid water to stay on the surface of Venus for over 2 billion years. And it depends on many conditions, because Venus also has a very slow rotation. In fact, Venusian day is longer than its year. And slowly rotating planets can actually cool down more efficiently than fast rotators. But it's a big question whether it has started with such a slow rotation or whether it was induced much later, for example, by some impact or by tidal forces. And we don't know yet. So we have to send missions to Venus to find out whether this scenario where it retained liquid water for over 2 billion years is correct or not. And hopefully on the surface, we might be able to find evidence of water alteration of minerals. But it would be hard because most of the surface of Venus is very volcanically transformed. Venus is a very volcanically active world, and there are only a handful of places in which very old rocks may be accessible for our probes, but it's not impossible. And there's another possibility, not just that it may have had conditions for life very long ago, but that in fact a very isolated part of Venus may still have conditions that would allow life to exist. And that's the atmosphere. And here on the right side, we see a diagram of the Venusian atmosphere. Here's the temperature. We see that it's very high near the surface, over 400 Celsius. But then it cools down as we go higher, and also the pressure decreases because on the surface of Venus, we have almost 90 atmospheres pressure. And that would be also quite hard for life, although pressure is not such a big complication, as we will see later, but the temperature is. And here in the cloud layer, between approximately 48 and 68 kilometers above the surface, we have temperatures and pressure that are very similar to the surface of Earth. Of course, the atmospheric composition is extremely different. Almost all of the atmosphere of Venus is carbon dioxide, and the clouds are composed mainly of sulfuric acid with some water. And the environment is extremely acidic. But it's probably not such an extreme complication for life as we know it, because we are aware of extremophile microbes here on Earth that are able to survive extremely high acidity and low water availability, and that are also quite ingenious in extracting biogenic elements from their environment. And this is one of these organisms. It's Cyanidium caldarium. It's a unicellular photosynthetic microbe that is able to survive in hot acidic vents. And it's also good at surviving quite high radiation doses, which might also be a problem in the atmosphere of Venus. So it seems that although the environment is very extreme, all of these obstacles could be overcome by life, and it might be able to adapt. And although it's quite hard to imagine that life would arise in this kind of environment, if Venus had liquid water on the surface in the past, it's not inconceivable that microbial life may have migrated to the cloud environment. Here on Earth, we see that the atmosphere contains really a high number of spores of bacteria, or even living bacteria and archaea, protozoans and other organisms, or even fungi spores, so that life can be transported from one place to another by winds in our atmosphere. And if something like that existed on Venus a long time ago, it's not inconceivable that life may have adapted to the cloud environment entirely. So it's a good place to look for life, and it wouldn't be very expensive or complicated because it would require sending atmospheric probes capable of sampling the clouds and having, for example, some mass spectrometers or Raman spectrometers to identify molecules that we associate with life. So hopefully future missions will include such instruments, and we will see whether this hypothesis of life in the clouds of Venus is correct or not. But let's move to Mars, the red planet, the fourth planet from the sun, and one of the most famous targets for the search for life in our solar system. And Mars also may have been similar to the Earth quite a long time ago, but nowadays it's a desert planet. And it has been so for a very long time likely, and we have known this even in the 19th century. And when astronomers such as the Italian Giovanni Schiaparelli observed Mars, they thought they saw something like channels in this desert. And although Schiaparelli never said that they were artificial, it got translated as canals into English, which implies that it was built artificially. And this kind of thinking spurred lots of fantasies about advanced civilizations on Mars. And writers such as George Herbert Wells here wrote stories like The War of the Worlds, where Martians escaped their dying desert planet and wanted to take over the Earth. But even in the times of Schiaparelli and Wells and proponents of Martian civilizations, such as the American millionaire Percival Lowell, who was sort of a fan astronomer and wanted to support the search for life on Mars and the search for Pluto and other causes. Other scientists were convinced that Mars lacks the conditions for life. And here we see Alfred Russel Wallace, who is the co-discoverer of natural selection along with Charles Darwin. And in fact, he wrote a short book called Is Mars Habitable? A critical examination of Professor Percival Lowell's book. Because as I said, Lowell was very much into the thinking of life and even civilizations of Mars. And Wallace didn't really think that it was possible. And later on in the 20th century, some people were trying to observe spectral signatures of life on Mars, some molecules that we associate with life. And several Soviet and British scientists thought that they observed signs of photosynthetic activity, but it was later shown that it was just contamination observed here in the Earth's atmosphere. But was Mars always such a desert planet? It doesn't seem so. When we look at the topographic map, we see something peculiar because northern hemisphere is covered with lowlands with very few impact craters. It's very different from the southern hemisphere. And we might even imagine this blue to be an ocean. And it's in fact possible that Mars may have had liquid water ocean in this lowland in the northern hemisphere. And for a long time, scientists were searching for the shoreline of this putative ocean. And a few years ago, it was discovered why a clear shoreline was not observed, because tsunamis that were made by impacts of asteroids or comets may have erased parts of this shoreline, and we now see the geologic evidence of that. And apart from this, we see evidence of liquid water in the past on Mars, such as quite vast networks of river channels, and we see chemical evidence that was observed, for example, by the Mars Science Laboratory Curiosity in the Gale craters. Gale crater, where it discovered chemically altered rocks that must have been in contact with liquid water at some point, clays that are only made by contact with water. And nowadays we see lots of ices on Mars under the surface. We even see something that looks like moving glaciers. And of course, on the poles of Mars, we see lots of not only carbon dioxide ice, but especially water ice underneath it. So Mars still has quite a lot of water, although nowadays it's solid and we can't see any liquid water on the surface. There are some indications that there might be transient liquid water, probably very salty on the surface, such as these flows that the recurring slope lineae, these like dark streaks we see. But spectral observations show that it's unclear whether they are made by water at all. And even if so, it's extremely salty and probably unconductive for life as we know it. And nowadays, liquid water can't exist on most of Mars because of the low pressure. The Martian atmosphere is extremely thin, and water needs not just high enough temperatures, but also high enough pressure to exist as a liquid. And that is lacking on Mars, apart from very few places such as the Hellas Basin. But still, it looked like a promising place to search for life in the past as well as now. And in fact, in the 1970s, the first and so far only predominantly astrobiological probes were sent to Mars. And these were the Viking landers. Here, a prototype shown with Carl Sagan, who was this kind of spiritual father of these landers. And what they discovered was very interesting because the results were inconclusive. Several experiments found no signs of life. For example, when they were looking for photosynthesis or just heating samples from the Martian regolith and seeing whether there are organic molecules. But there was this experiment called labeled release, which used radioactively labeled carbon-14, and its goal was to find out whether some life might metabolize this carbon and then release it in the form of carbon dioxide. And in fact, this was exactly what was observed on both landers. So some scientists thought that it was a sign of metabolic activity on Mars and that we have discovered life. But as I said, all of the other present experiments found no indications that life existed there. And only in 2008, when the Phoenix lander landed on Mars, it was found why we were getting these disparate results, most likely, because in the 70s, we had no idea about the detailed chemical compositions of the Martian regolith. And what the Phoenix lander found was that there are these salts called perchlorates, which are very reactive, very chemically aggressive. And these could have reacted with the molecules with the carbon-14 and made this radioactively labeled carbon dioxide. So they may have contributed to a false positive in the labeled release experiment, but on the other hand, they could have potentially caused false negatives in the other experiments by destroying any present organic molecules when heated. So the Viking results remain unclear, and in its time, it was really ingenious, and future probes, either to Mars or other bodies, should definitely include other experiments that are centered on finding signs of metabolism. But it's not enough in itself, and to utilize such experiments, we need to know as much as we can about the environment that we're sending the probes into. So that's what the Viking landers showed us most prominently. And nowadays, several missions to Mars are being prepared to search for life. And one of them is the ExoMars rover and lander. And the rover, dubbed Rosalind Franklin, is equipped with a drill, which we can see here. And it can drill to up to 2 meters below the surface, which is important because radiation on the surface of Mars could destroy any life or even chemical signatures of extinct life. So we need to drill deeper, and also deep inside the surface, there's also a chance of, for example, the existence of hydrothermal vents, where there may be heat and chemical gradients and capsules of liquid water, so an environment conducive for life. And another probe that is aimed to the search for life is NASA's Mars 2020 rover, which should be very similar to Curiosity, working on Mars right now. And it will also have a drill, but that one will only have the depth of about 10 centimeters, so it's not really ideal. The ExoMars rover should be able to find signs of life, whether extinct or extant on Mars. And it's not without a chance, because it's conceivable that in the isolated higher pressure areas, there may be periods with transient liquid water enabling some seasonal growths. And it was hypothesized that these may be responsible to the spikes of methane production on Mars that we have seen both with orbiters and in the Curiosity lander. But it's also possible that the methane is produced completely without any action of life. Another possibility is life inside rocks. This is what we can see on Earth in many arid desert areas, such as the Atacama Desert, where endolytic life was found by many groups of researchers, or in the Arctic and Antarctic, where this kind of environment enables it to survive not just the extreme aridity, but also the extreme cold, which is also the case on Mars. And as I've mentioned, there might theoretically be some hydrothermal vents beneath the Martian surface, and we have seen kind of signs of the past activity of hydrothermal systems on Mars with the probes that have visited it so far. And just last week, the InSight lander has shown us that there are in fact Marsquakes, that Mars is not completely geologically dead. And that makes the case for some isolated areas where these vents might still exist and provide isolated environments for life up to this day. And finally, last year, the Mars Express European probe observed what looks like subsurface lakes underneath the South Polar ice cap on Mars. And we see analogs of this on Earth, because underneath the Greenland ice sheet and the Antarctic ice sheet, we have seen very vast lake and channel networks. And we know that there is life because several of these isolated lakes were drilled into, most famously the Vostok Lake on Antarctica. And it had a surprising diversity of microbial life. So this kind of environment is very hopeful for the search for life on Mars nowadays. So we'll see with future probes. But let's move further in the solar system, especially to the icy moons of the giant planets. And here we see Europa as imaged by the Galileo spacecraft, which visited Jupiter now over 20 years ago. And in this artist's depiction, we see it visiting Io, the innermost of the 4 Galilean moons. And Io is very volcanically active, and it has very few volatiles, such as water. But the outer moons, Europa, Ganymede, and Callisto, were shown by the Galileo probe to have liquid water oceans underneath the icy crusts, because we can see the evidence of the induced magnetic fields that can only be created by some conductive layer as the moons move in Jupiter's vast magnetic field. And a good conductive layer is liquid water, and it's basically not conceivable it might be anything else in this case. And the gravity measurements also supported it, and also Europa has this very smooth surface with very clean water ice, and it looks like it's very geologically active. There are almost no impact craters we can see, and it has these lines and ridges. So all of this points to the existence of the liquid water ocean underneath the icy crust. But the Galilean moons, the icy ones, are not the only places with liquid water under ice. The Cassini probe, which visited Saturn, showed us another such a place, and that's the small moon Enceladus. Again, we see very clean, smooth water ice surface with these lines and ridges, and although it has more craters in some areas, here we see practically none. And there's also Titan, the large Saturnian moon, which is covered by an atmosphere. It's the only moon in the solar system that has a substantial atmosphere. And we were wondering what's underneath it from the beginnings of good astronomical observations from distance. And the Galileo probe and its Huygens lander showed us. And the icy moons featured in lots of fiction, most famously the Space Odyssey series by A.C. Clarke. And the books were set around Europa, the Jovian moon, and they depicted life existing under the ice. And nowadays, this kind of most informed image we have of Europa is that there is icy crust that is several kilometers thick, from 2 kilometers in the thinner places to maybe 20 or even 30 in the thicker places. Then there's the ocean that may be approximately 100 kilometers deep, so much deeper than the ocean here on Earth. And then there is this rocky core with the inner metallic core. And the ocean may have environments conducive for life. And it was hypothesized already in the late 20th century that if it has hydrothermal vents on the bottom of the sea, it may be a good environment for methanogens, microbes that create methane by metabolizing hydrogen and carbon dioxide, which are present there. And these in turn may provide nutrients for other microbes that in turn break down methane into these components. And on Earth, we see quite a vast microbial diversity in this kind of environments. And there is no reason to think that Europe would be lacking in these, because tidal forces around Jupiter as it moves provide enough heat to melt parts of its interior and not only keep the liquid water ocean liquid, but also probably create this kind of vents on the bottom. And the surface may provide other kinds of nutrients because Europa moves inside Jupiter's radiation belts. And as the strong radiation bombards the surface, it may not only break down molecules into more simple components, but also facilitate creation of more complicated ones. And molecules spewed by Io's volcanoes also rain on the surface. And as it changes on the geologic timescales, these molecules may migrate from the surface into the inner ocean and provide food for putative microbes. And NASA scientist Dr. Greenberg also hypothesized that if there are some transient liquid water capsules underneath the surface, let's say 5 to 10 meters underneath it, there still may be enough sunlight for photosynthesis, and by the several meters of ice, enough protection from the radiation. And although this is not very likely, it's still conceivable that photosynthesis might exist there. So Europa is quite a hopeful place to search for life. And it was also depicted in lots of fiction, such as the movie Europa Report, or short stories such as Alastair Reynolds' Spy in Europa, or Gerald Norden's War, Ice, Egg Universe, which I quite recommend. And here we see one of these black smokers, the hydrothermal vents on the surface, on the bottom of the Earth's ocean. And Enceladus is another hopeful place. And here we see that it has these plumes, these geysers near its south pole, and the Cassini probe not only photographed them, but also flew right through them. And its spectrometer was able to tell us that it has clay particles, which look like evidence of hydrothermal activity with lower temperatures, but still quite good for putative microbes, and that it has quite complex, very large molecules. So although we don't have any clear indication that it has life, we have all the indications that the conditions are conducive for life. And researchers such as Ruth Sophie Taubner in the Vienna University were trying to cultivate methanogenic microbes under the conditions as similar as possible to the ones that we think are present in the Enceladus Ocean, and they thrived there. So it's very hopeful. And it's interesting to also look at how old the moon is, because it was hypothesized that it may not be as old as the solar system itself, that in fact it may be a second generation moon formed from material by some large moon that was broken either by the tidal forces or by some very large impact. And this was thought by some scientists because of the tidal dissipation measured in Saturn by the Cassini probe. But then we're not completely sure how accurate these measurements were, so it's still an open question. And the moon may be as old as the solar system, so approximately 4.5 billion years, but it may even be as young as 100 million years, so that's extremely young. It's important to send more probes there to test these possibilities and to search for life. Since it has these plumes spewing into space during each apochronium, the most distant point from Saturn in Enceladus orbit, it's very easy to sample these plumes, and with better instruments than the Cassini probe had to search for molecules that we associate with life. And these are the Earth analogs of what may be present on Enceladus. These are the white smokers, lower temperature vents on the ocean's bottom. But Titan, the large moon around Saturn, is also very interesting in this respect, because not only it has a subsurface ocean, likely rich in ammonia, but it has these surface lakes and seas, which are not filled by liquid water because the temperatures are extremely low there. They are filled by simple hydrocarbons, especially methane. And there are several possibilities of how life might exist in these, because there might be isolated water droplets acting as membranes. And here on Earth, we can see quite a rich diversity of microbial life in water droplets, in asphalt lakes on Trinidad and Tobago and other places. And it was also hypothesized that life may not need water at all, that methane may act as an alternate solvent for life. And for that, we would need these reverse membranes, because life on Earth has membranes that have two layers, and the outer layer is called hydrophilic, sort of water-loving. It's in contact with water, and to the inside, it has these hydrophobic ends of the lipids, the molecules that the membrane consists of. And if we reversed it, it would be capable of existing in a non-polar solvent such as methane. So that's also not inconceivable. And it's a good place to search for life that is very different from life as we know it here on Earth. And several decades ago, it was hypothesized by Carl Sagan and his colleagues that life might even exist in the atmospheres of gas giants such as Jupiter. And here we see an image from the original Cosmos series depicting these kind of floaters in the Jovian atmosphere. And it's not very likely, and it's hard to imagine that there might be any stable enough environment for chemical reactions to enable the origin of life and long enough existence of even simple organisms. So it's more of a fantasy that's used in many science fictional stories. For example, A.C. Clarke's Meeting with Medusa. But of course, we can't completely exclude it. And such lines of thinking even spurred the hypothesis that such an atmospheric habitable zone may exist in the atmospheres of brown dwarfs, this kind of objects in between planets and stars, not massive enough for fusion to start in their centers and for them to become stars, but more massive than planets are. So it's another possibility for finding life outside the solar system. But around the gas and ice giants, we have moons that, although they probably don't have any liquid water nowadays, still may have exotic environments for life. This is Neptune's moon Triton, as imaged by the Voyager 2 probe. And the Voyager 2 saw something that was likely nitrogen geysers. And if Triton has transient liquid nitrogen capsules under the surface, it still may be an environment conducive for very exotic life that we might also search for in the Kuiper belt and beyond, in places such as the dwarf planet Pluto and its moon Charon. And we see lots of geologic diversity on Pluto. It's certainly not geologically dead. We see bright areas with few craters, such as the Sputnik Planum here, and on the other hand, very dark areas such as the Cthulhu Regio that are covered with lots of impact craters and with this kind of complex molecules called tholins. And here on Charon, we see this feature called the Serenity Chasma, and it looks like an extensive feature, something that is created when the crust cracks by extending. And one possibility of why we might be observing this is that Charon may have had liquid water underneath the icy crust in the past. But as it froze out because there was not enough tidal or radiogenic heat to sustain it, it expanded because normal ice is has more volume than water, as we can see everywhere on frozen lakes on Earth. It may have caused these extensive geologic features such as Serenity Chasma. And Pluto and other such worlds were also imagined by science fiction to be sites of life, but mostly in the types of fiction depicting civilizations that came from other solar systems to colonize it here and that landed on Pluto. And in fact, very few stories deal with something that might be called indigenous Plutonian life, and even fewer stories feature something realistic in this respect. But it's not inconceivable, and works such as Hauke Hussmann's model showed that liquid water might exist even in the Kuiper belt. Here we see Pluto or Eris, and even a very distant dwarf planet Sedna. And with enough insulation by the thick icy shells above and just a few resources of radiogenic heat in the rocky core and lots of sort of anti-freeze components like ammonia or salts, these objects still theoretically might have liquid water up to this day, although it would be ammonia rich and extremely salty, so very different from oceans conducive for life as we imagine it here on Earth. But I've mentioned the possibility of exotic life, and for example, in the pockets of liquid nitrogen that may exist for a short time. And these may be, for example, life that is based not on carbon as the backbone, but on silicon. And if we look at silicon life in science fiction, we mostly see it in very high temperature environments, or we see creatures such as the Horta in the Star Trek episode, The Devil in the Dark. But these are very, let's say, unrealistic depictions from the point of view of science, but scientists such as William Baines have tried to imagine some kind of functional and structural analogs of carbon components that life uses on Earth, but made by silicon as the backbone, and molecules called silans and silanols may provide such analogs. And these are stable in very cold environments that contain no liquid water and no free oxygen. So liquid nitrogen may in fact be a good environment for these. And very short-lived transient habitats are even conceivable in comets, although it's extremely unlikely that they would feature any kind of life that would have time to evolve, especially into something complex. And finally, it's not out of the question that there is another planet in the solar system, the so-called Planet 9, because models of the orbital evolution of the solar system show that it may have started with more terrestrial planets than just the 4 that we see now, and that by gravitational interactions with Jupiter and other giant planets, one may have been kicked out either entirely or on a very elongated, faraway orbit. And we know that in the outer reaches of the solar system, there is no gas or ice giant, no Jupiter, and even no Neptune, because the WISE probe has conducted a whole sky survey in the infrared part of light, and it would see the heat emissions from such large planets, because they emit more heat than they receive, especially Jupiter. And it would, though, not see something like the Earth or some, let's say, super Earth or mini Neptune. There might not be enough heat emissions for this, for WISE to detect such a body. And researchers such as Mike Brown and Konstantin Batygin are thinking that there might be this 9th planet, because we see some peculiarities in the orbits of comets and dwarf planets in the outer reaches of the Kuiper belt and the Oort cloud. So it looks like they might be interacting with some as of yet unseen massive body. And we will see with more observations by powerful telescopes whether they are right and whether this planet actually exists or not. And to depictions of life in the Kuiper belt, we might turn to even some of my stories, the Symphony of Ice and Dust. And although it doesn't feature indigenous life, it features the discussion of a possible subsurface ocean on Sedna. Here we see the artist's depiction. It's a small dwarf planet on a very far away elongated orbit, and it takes over 10,000 years for Sedna to orbit the sun. In contrast, Pluto only takes 250 years approximately. So we see that this orbit is really elongated and really, really long. So even such environments might theoretically contain places conducive for life as we know it. So is that the end of it? Are these all of the possible environments that life may have existed in the past or may still exist in the present in the solar system? Certainly not. I mean, basically, everywhere may have been in the past or will be in the future some short-lived transient habitats. Last year, there was even a scientific paper discussing a very short-lived period of the habitability of the Earth's moon. But again, it was such short-lived that it may have had some atmosphere and liquid water on the surface, that it's very difficult to imagine that any evolution of life may have taken place there. But again, it's not out of the question, we cannot exclude it. And as scientists, we should bear this possibility in mind and try to form some hypotheses of how to test it. For for example, some molecules to search for. And if we fail to find these and falsify the hypothesis, it means that life most likely wasn't there. And if we found molecules that would support such a hypothesis, it doesn't mean definitely that life was there, but it's indicative that it may have been. And that's the case for all the places I have mentioned. We have to be sure of what we are searching for and then just go there, because potential habitats, although many of them seem very unlikely, are abundant throughout the solar system, and we have no idea whether there is life. And in many of these places, we have only a very vague idea of the exact conditions. So to find out whether there really is life, we need to send more planetary missions to explore them. And here we see that already the solar system is full of missions to different kinds of objects, not just the planets and their moons, but also asteroids and comets. And still we need more of them, and luckily many of them will still launch. So that's it, and I hope that you have many questions, and I'm looking forward to answering them. Thank you.
Thank you so much, Julie, for this exciting talk. It's fascinating to realize we might have neighbors in our own solar system. So we are a bit short on time now, but we can spend a few minutes for a short Q&A session. I'm gonna have a look to the questions we received so far, and I propose to read those questions to you and you try to answer them. Is that okay, Julie?
Yeah, of course.
Okay, so I have a question here from Wilson Canelo. I think he's from Colombia. And he's asking, is it possible to find life on solar system planets, Galilean planets, for example? So I think he's referring to the Galilean moons, which conditions are similar to extreme conditions on Earth. You already covered this topic, but maybe you could give a little fresh up on that.
Yeah, of course. I mean, the inner ocean of Europa, the innermost icy Galilean moon, may be similar to the oceans of Earth in terms of conditions, although we have no idea, for example, whether it has oxygen or how much. It's still an open question, and we don't know how many nutrients it has. But still, even in this very vague idea we see that it likely has conditions for life as we know it. And speaking of the outer Galilean moons, Ganymede and Callisto, it's more complicated there because they are larger and more massive than Europa, and the pressure on the bottom of their oceans is such large that there must be what we call high pressure ice, water that has been pressurized so much that it became solid. And unlike the good hexagonal ice, crystal ice that we know from Earth, this is of course denser than water, so that it stays on the bottom and doesn't float like the ice that we know. And this high pressure ice isolates the water oceans from the rocky cores so that it may potentially prevent any cycling of biogenic elements, and it might make it more complicated for life to arise there. But also there are lots of models showing that there might be sort of vents or ice volcanoes going throughout all of these layers of high pressure ices. So it's still possible that biogenic elements might be recycled effectively, and that even these moons might contain conditions for life. But Europa is easier to search for life because its icy crust is certainly thinner. And in the future, we might even send some probes that would be able to melt or drill through it. And it's hard to conceive in the cases of Ganymede or Callisto. Yeah.
Yeah, okay, great. We have also Daniela Bunea from Romania. She left a comment, a very nice comment prior to this webinar, saying that she's an avid reader of science fiction and also a teacher and the mother of a boy. And she's happy to listen to take part of this webinar, and she thank you for being here. And in fact, she just left a question, and Daniela would like to know which was your first science fiction book that you clearly remember reading.
Well, I think that it is, and I might actually not be saying the English title correctly because I read it in Czech in translation, but it's the Fountains of Paradise by A.C. Clarke. It's about an engineer who works on building a space elevator here on Earth. And I really loved it. So that's the first I remember clearly. And one of the first were also novels by the Polish science fiction writer Stanisław Lem, like Solaris or The Invincible. And these feature very exotic forms of life. In case of Solaris, a planetary ocean that is a live organism. And in case of The Invincible, again, I'm not sure if it was translated in English with this title, that it features these kind of robotic organisms acting as this kind of a big society.
Yeah, Daniela just replied saying that Arthur C. Clarke is her favorite author. In fact, we have also another attendee from Portugal, José Saraiva, and he's an avid science fiction book reader. I'm sure he read all the books you mentioned, and most sure he would like to talk to you about those. I'm going to jump quickly to another question because we are really short on time now. There's Tyrion, who is following us on YouTube, and I think his question was already somehow addressed by you, but maybe you can also go to it again. He asks, is that UV absorption in spectrum of Venus' atmosphere is still unexplained? Could it be from some kind of life, he asks?
Potentially, yes. There's this unknown UV absorber, and it's thought to be potentially large molecules that are made by sulfur. And it was even hypothesized that these may act as a shield from the ultraviolet radiation that is produced by microbes in the Venusian atmosphere. So that's one kind of possibility, but we have to test it. Of course, with all of these speculations that I have mentioned here, we have to form some clear predictions of what we expect to see in case there's life, and then we have to go there and see if we are correct or not. So it's still possible, yes.
Yeah, not directly related to this question, but while you were doing your presentation and talking about Venus, I was thinking that with temperatures above 450 degrees Celsius, with very high pressures, above 90 times that we have on the surface of our planet, and with sulfur, which we could say it smells like rotten eggs, more or less. So I was thinking that if there is hell, it sure must be on Venus, don't you agree?
Yeah, but even there, we might theoretically imagine some exotic forms of life.
Exactly.
I mean, even some researchers have speculated about life in supercritical liquids, such as supercritical carbon dioxide, which is the case on the bottom of the Venusian atmosphere. And I mean, if we look into speculations about really exotic life, We might even include Jupiter's volcanically active moon Io in the search for life, because underneath the surface there might be liquid sulfuric acid or sulfur dioxide, and even these might theoretically act as solvents for some kinds of life, using either carbon or sulfur or silicon as the backbone. But these are really wild speculations, and so far we have no possibility to test any predictions related to them. So
yeah, definitely.
right now we should start with Mars and with the icy moons, especially Enceladus, and also with Titan and its methane seas. These are the places that we can go there, and also the atmosphere of Venus.
Yeah, definitely. And this links to another question from Tyrion, who is from Moravia, and asking if there are any other possible elements besides carbon and silicon on which life could be based on.
Yeah, well, it was discussed that, for example, even phosphorus or boron or nitrogen may act as backbones for molecules for some exotic life, and or it might have some combinations of these, such as boron plus nitrogen. But all of these have several disadvantages, and the most important one probably is that carbon is far more abundant than the other conceivable elements as backbones for life. Carbon is basically everywhere. And speaking of alternative solvents, water has the advantage of being everywhere. I mean, in the solar system, if we don't restrict ourselves to liquid water and just look for water in any form, there are even water molecules on the sun, and we have water ice on Mercury and on the moon. We have water vapor on Venus, water ice on Mars. It's everywhere. So carbon and water seem like the most likely option, not just because we see this combination here on Earth, but because they are really abundant everywhere we look in the universe. But that's not to say that there are not other possibilities.
Yeah, definitely. Just one last question regarding the Viking missions. Why do you think we haven't had follow-up missions with the same scope on Mars? And do you think that's going to happen soon?
I hope so, and I think it was because how inconclusive the results were. In theory, this should be exactly the reason to send another mission.
Exactly.
But in practice, it's not just up to scientists, it's up to politicians and policymakers who allocate money to NASA or to other national space agencies. And these don't like inconclusive results. These like as clear answers as possible, even though science usually can't provide them. So it's mostly a money or politics issue, in my opinion. But of course, I'm not familiar with the inner political workings of NASA in the Viking times. But
yeah, it's maybe an example how politics is important in science as well. Although typically scientists are not worried about that, but it's very important, in fact.
Another example is the upcoming Europa mission by NASA, which has an avid proponent in a Texas Republican senator, but he was not re-elected in the last election. So the probe might be losing a bit of support in this case, but since it's already quite far in the making, or not the actual making, but you know what I mean?
Yes, all the study and all the preparation for the mission. Yeah.
Exactly.
Hopefully it goes through. We are all hoping for that.
Yeah, and
because Europa is a real candidate to find life on that liquid ocean beneath the icy cap, like you said. Because like we find life on our planet on the bottom of oceans closely to the thermal vents. maybe you can find something like that in Europa, like you referred.
Yeah, exactly.
Yeah.
And there's a European probe being prepared called the JUICE, Jupiter Icy Moons Explorer. And it will make 2 flybys of Europa and several of Callisto. And after some flybys of Ganymede, it will go into orbit of Ganymede. So it will explore all these 3 icy Galilean moons. It will be very interesting.
Yeah, definitely. Okay, unfortunately, our time is up and we have to close here our webinar. Thank you so much again, Julie, for participating in April's Europlanet webinar.
For inviting me. And I hope
it was a pleasure having you here in our session.
Thank you.
I wish you all the best and for your baby as well.
Thank you.
Okay.
Yeah.
As for you that who have joined us today, thank you so much for attending and participating. Don't forget to follow Europlanet on Facebook and Twitter, and feel free to ask your planetary questions there. You can also watch this video and previous ones on the Europlanet YouTube channel. And you can find more information about this webinar in the Europlanet webinars and Galileo teacher training program web pages, whose links you can find in the description section of this video. We will meet again for our next webinar in May. So it's going to be on the 13th of May, and it's going to be about volcanism on Mars. So if you want to be part of the announce list, you can find all information in the Europlanet website. So stay tuned. I hope to see you next time. Bye-bye for now. Nuno out.
Bye-bye.